to be going over nervous system receptor sites. Now, when we're talking about nervous system receptor sites, we're actually looking at the divisions of the autonomic nervous system that are broken down into two divisions, your sympathetic division and your parasympathetic division. It may be helpful to think of these as their other names of sympathetic of the thoracolumbar division, and for the parasympathetic, the craniosacral division. And these are named based on where those nerves come from. So the nerves of the autonomic nervous system are going to exit the central nervous system, or the preganglionic nerves, and they're going to enter the autonomic ganglia. You have other nerve fibers, the postganglionic nerves. They're going to exit the autonomic ganglia and extend out to the target organs. Now, the autonomic nervous system has two functions. You get your sympathetic nervous system and the parasympathetic nervous system. The ganglia of the sympathetic nervous system are located close to the spinal cord, and the ganglia of the parasympathetic nervous system are actually located closer to the target organs. There is no actual physical connection that exists between these two nerve cells or between the nerve cell and the organ that it innervates. Instead, you have this space there between these nerve cells and the target organ, and this is called the neuroeffector junction. You've got these special chemicals called neurotransmitters. They're going to conduct the nerve signal between the nerve cells and between the nerve cell or its target organ. Now, these neurotransmitters are going to be released from these presynaptic neurons, and then they're going to act on the postsynaptic neurons or on the designated target organ. When it's released by the nerve ending, the neurotransmitter is going to travel along the synaptic gap, and it's going to activate the membrane receptors on these adjoining nerves or target tissues. And then that neurotransmitter is either deactivated or taken back up into this presynaptic neuron. So our primary neurotransmitters of the autonomic nervous system are going to be acetylcholine or norepinephrine. Your acetylcholine is going to be utilized in the preganglionic nerves of the sympathetic nervous system and the pre- and postganglionic nerves of the parasympathetic nervous system. And the synapses that use your acetylcholine as the neurotransmitter are going to be called cholinergic synapses, and the ones that use your epinephrine and norepinephrine are going to be your adrenergic receptors. Now, when we are talking about your adrenergic receptors, you have several different types, but you've got really 5 core and then another one. So your adrenergic receptors are going to be alpha 1, alpha 2, beta 1, beta 2, beta 3, and dopaminergic. We're going to be focusing primarily on your alpha 1, beta 1, and beta 2s, but you do need to be familiar with the other ones as well. So your alpha 1, its primary action is going to be peripheral vasoconstriction. So this is going to help vasoconstrict, which is going to kind of shunt or redirect blood flow as needed. This is going to have a positive inotropic effect on the heart, so it's going to increase the contractile force of the heart, and it's going to decrease the heart rate, which will have a negative chronotropic effect of the heart. Now your alpha 2. Alpha 2 is going to decrease your catecholamines in circulation, and this is going to cause vasodilation and decrease blood pressure. Beta 1 is going to cause increased heart rate, which is a positive chronotropic effect. You're going to have increased contractile force, so a positive inotropic effect, and an increased automaticity, so it's going to have a positive dromotropic effect on the heart. So primarily, it's all going to work on the heart. All right. Beta 2, peripheral vasodilation a little bit. Bronchodilation, which is the primary thing that we see it for. It also has uterine smooth muscle relaxation and gastrointestinal smooth muscle relaxation. So overall it relaxes the smooth muscles everywhere pretty much. Now with this, the one way you can remember for your betas, beta 1 is going to work on the heart. Beta 2, there's 2 lungs, so it's going to work primarily for our uses in the lungs. Now beta 3 is also exists, and it's for lipolysis and thermogenesis for the most part. So like heat regulation, metabolism, that kind of stuff. And then your dopaminergic receptor sites, these are going to be in the mesenteric arteries and your renal areas, and these are going to cause vasodilation of those, which will hopefully improve perfusion to those areas. You know, we said that you've got your pre and your postganglionic parasympathetic nerve fibers, and they're going to use acetylcholine as their primary neurotransmitter. Now, there are 2 types of your acetylcholine receptor sites, nicotinic and muscarinic. Now, your nicotinic receptors are found in all of your autonomic ganglia and at your neuromuscular junction that initiate your muscular contractions as part of the voluntary nervous system. Your muscarinic, which is where we're primarily concerned with it, are going to be found in your organs throughout the body, and these are responsible for kind of promoting that parasympathetic response. These are going to be in your heart, and you will see them as a decreased heart rate. And this one's located specifically in the sinus atrial node. You're going to have decreased conduction rate. This is going to be in the AV node. You'll see it in your arterioles, where you have dilation of your coronary, your skin mucosa, and your cerebral arteries. You'll see it in the GI tract. It will release your sphincters, increase your gastric motility, increase your salivation for your salivary glands. You'll see it in your lungs with bronchoconstriction. You'll also see increased mucus production. You will see it in your gallbladder with contraction and releasing of the bile there. You'll see it in the urinary bladder for relaxation of that urinary sphincter. You'll see it in the liver for the glycogen synthesis, the lacrimal glands for the increased tearing, constriction, pupillary constriction, and it can also be responsible for erection in the penis. So, quick comparison. In the heart, sympathetic stimulation is going to increase the heart rate, increase the contractile force. Parasympathetic is going to decrease that rate and decrease that contractile force. For your lungs, sympathetic stimulation is going to bronchodilate, parasympathetic is going to bronchoconstrict. For your kidneys, sympathetic stimulation is going to decrease your output, and parasympathetic is not going to have a lot of change on the kidneys. For your systemic blood vessels in the abdomen, sympathetic stimulation is going to constrict them. The muscles, alpha is going to constrict them for the sympathetic, and beta is going to dilate the perfusion. For the skin, sympathetic is going to constrict it. In the liver, sympathetic stimulation is going to release glucose, and the parasympathetic stimulation is going to synthesize glycogen. In the pupils, sympathetic is going to dilate, parasympathetic is going to constrict. In the sweat glands, sympathetic stimulation, lots of sweating. Parasympathetic, not so much. The metabolism, sympathetic is going to increase. And in the skeletal muscle, increased strength, whereas the parasympathetic, not as much, and you have relaxation of those sphincters.